These are hints for the homework, chapter 4 for exponential and logarithmic functions. It says preview test, but Blackboard calls everything test. This is really the homework quiz. All right. So here, question 1. Inverse functions match the following. So here you have from chapter 4.1, whatever page that number that is on, problems 9, 10, 11, 12, 13, and so on. And then over here, you have the answers, and I just can give this away. Yes, both functions are inverses of each other when you look at these, and the other two in this case don't apply. By the way, this answer here I have a number of times, none of the above because the instructor made a typo. I had very little time to type this all up, so the potential for there being a typo somewhere is quite there. I intended to get the right answers listed on here, but let me know if you find a typo somewhere. All right, so this is chapter 4.1. Here's chapter 4.2. And I really advise you to go to this link here for Desmos. There you go. Just copy and paste it. And you will see that I tried to graph these these diagrams from the book. And you will see that they're either one-to-one or they're not. And again, we can hopefully dismiss the typo here. And well, this has really no meaning to the math problem. And by the way, of course, the first one here with the Desmos link, yes, that's true. In fact, the instructor did an excellent job and so on. All right, the next one, excuse me, is about graphing. So these problems here from chapter 4.2, exponential functions. And yes, I'm sure you can believe me that I tried to graph them all on this one here correctly. So go ahead and check out that link. Actually, I figured I might as well show you. So here's the Desmos link. There it is. I just copy and pasted it in up here, right here. And then you can see them all graphed here, these exponentials. And these are the original equations from the problems. And you can match them up. You can turn one. Oh, I didn't mean to do that. Oops. Didn't mean to delete it. I just meant to squeeze it over here. But if you turn these off here one at a time, then you see, okay, this one is the first one. Turn this one off. There's the next one. There's the next one, and so on. And that reminds me, I could go back to the other problem I showed earlier. So this one here from question 2, because I have the Desmos link there. So I copy and paste it, and here it is. And graphing them all at once, that looks pretty cool, I think. In any case, any one of these, the book, I believe, actually doesn't list these equations, but they just show the diagrams, and then you just look at it. Okay, that diagram looks like this, or here's another straight line, or here's a logarithm. And again, this is a little bit off the screen here because my screen is actually so small, or it's this one here, or there's a polynomial, or this one here, there's another polynomial, and so on, or all of them together. Again, that looks pretty cool. And so, yeah, you can look at this second problem here. I forgot earlier to just pull up the Desmos. All right, let's go to the next one here. So I don't think I did this one yet, did I? Nope. So here we go. And again, pull up the Desmos. There it is. And then look at them over here and see how they look like. Look how they compare. And the hint is that, yeah, that's the way they are in the book. And top of my head, they're kind of in the correct order, but notice that one of them reuses the previous answer. So a couple of these 4 are exponentials. And when you look at Desmos, you can see which ones. I believe it's these here, obviously, as the equations suggest. And these are the diagrams that you actually see in the book. All right, next problem, logarithmic functions. So here, just plug these in. And notice I made up a few. So as you plug this straight onto your calculator, you take the 7.8 on the Richter scale. He was actually American, so Richter scale, I guess. 7.8 is the exponents. You take 10 to the 7.8 on your calculator, you come up with 63 million. And this one is made up. Well, the earthquake in Chile is not made up, but it's not in the book. So 8.3 in Chile and 10 to the 8.3, excuse me. And then the Alaska 64 earthquake, 9.2, 10 to the 9.2. And notice on a Richter scale, they don't look that much different, 7.8 to 9.2, but their intensities are quite different. Here we have this big earthquake in 1906 that killed a lot of people and devastated a big city. It has an intensity of 63 million, while the Alaska earthquake in 1964 had 1.6 billion, much, much stronger. But of course, it was also in a much less populated part of the country. And then here, this other one, 90. All right, the next problem on the homework. This one here, properties of logarithms. So you're supposed to take these problems here from chapter 4.4 and rewrite them, simplify them, I guess, or rewrite them differently. And again, just a hint to the wise that these are actually in the reverse order when you look at these. And so are these. Also in the reverse order. So you solve these here and you come up with certain solutions, and you will see that actually one of these solutions is always extraneous, which means it seems to pop out, but with the logarithm it's such that all of a sudden you have a logarithm of a negative number, which you're not allowed to take, and that's the extraneous solution then. All right, and this one here. And this is the last one on the homework. So here, this is from chapter 4.6, logistic modes, and they still have exponentials and logarithms in here. But in this case, by the way, it is in the correct order. All right, so kind of. Notice that actually this one here uses another answer to a previous question. So it's kind of like this one is A, this one is answer B. This one here is also answer B, and then this one is answer C. And this here is perhaps answer C as well. You have to check that out, and then answer D, and so on. But you will see when you do these problems that the answers over here do make sense. All right, and those are my hints on the homework for chapter 4.